Providing access to clean drinking water is one of the most important engineering challenges of the 21st century. Although it affects low and middle income countries disproportionately, it is still a major concern in some high income countries. For example, in Canada, 73% of First Nation water systems are at risk of contamination. To respond to this challenge, engineers need to work with other professionals in order to ensure a sustainable solution. Let's explore how a chemical engineer, a civil engineer, a health scientist, and an ecologist would need to collaborate in order to provide safe drinking water to a First Nations community. The chemical engineer and health scientist would work together on the development of a filter, such as this biosand filter developed by Bushproof. The civil engineer and ecologist would then collaborate in order to ensure the safe transportation of this water to the community. Let's examine their roles more closely.
Chemical engineers apply the principles of chemistry, biology, physics, and math to solve problems that involve the use of fuel, medicine, food, and many other products. Therefore, we can say that chemical engineering is related to so many other non-engineering disciplines as well. They contribute to many working fields, such as biomedicine, food production, and recycling. As a result, chemical engineers play an important role in society to improve our lives. In this project, they will make sure the sand filter filtrates the water properly, and afterwards, they will check the quality of the water in order to decide whether it's drinkable or not with the help of health scientists.
Civil engineers design, construct, optimize, and maintain public infrastructure, such as the water pipelines in this project, so they must have a strong understanding of fluid dynamics. Pipelines are created, tested for leaks, then buried underground. Pressure is pumped into the water within the pipeline to make it move. Periodic maintenance on the pipelines are performed by the civil engineer to ensure that the pipelines are running safely and efficiently. There are many factors that a civil engineer considers when designing the water pipelines, such as the type of pipe, size and thickness, material, the distance of water transportation, what type of terrain the water pipelines travel over, and population density.
The role of a health scientist is a very important one, since they have knowledge about how the water will actually affect the people drinking it. Without a health scientist, the chemical and civil engineer wouldn't even know what they're working towards, what they're working to filter out. For example, what is the ideal pH of water for a human body? What nutrient byproducts are safe and unsafe for humans? Is phosphorus or nitrogen consumption safe? To answer the latter, say this water has been found to have 60 milligrams per liter of nitrate. To a chemical engineer, this may not mean much. A health scientist, however, knows that this is far over the acceptable level of nitrate in drinking water, and it could affect a fetus's ability to produce hemoglobin, making it dangerous for pregnant women to ingest. This could be an instance where consulting a health scientist saves a life.
BLS.gov defines an environmentalist as someone who uses their knowledge of the natural sciences to protect the environment. The environmentalist position is vital to the sustainability of the project. They would perform an environmental survey, assessing the technology and infrastructure of the project, thus making sure the water filtration and distribution system will not harm the environment. Furthermore, they will do research on the source of the water and understand the environmental impact of irrigating that water. It can be seen in many situations, such as the Aral Sea disaster, that without a proper environmental survey, water sources can completely dry up, which has devastating effects. It is vital that an environmentalist gives the green light for this project, because without it, the project could have devastating effects on the environment, or the source of the water could completely deplete, therefore making this project not sustainable. In the end, this project cannot feasibly be achieved without any of these core positions, as well as many others. It is vital that every position is able to perform their role in a way that is cohesive with all the others, otherwise the project will inevitably fail.